Hi, my name is Sang-baek Kim. I'm an associate professor in mechanical engineering. I'm doing research on robotics. So initially, I was very motivated by the copying natural animals, the animals in the nature, especially the land animals, like the exciting movement of the cheetah and then this muscle twitching from human sprinters and so on. But I also realized we have this missing technology in ground mobility. We sort of conquered the air and the surface of water. We still have a problem in the deep water, but we still haven't quite conquered the land we are actually living on. Like, we have no problem climbing upstairs and going over little obstacles. We have to rely on our artificial modification of the road so that we can use wheeled vehicles. We still don't have any technology we can bring impaired people or elderly people who have some mobility issue, bring them from their home to our workplace seamlessly. They have to do this awful transition from their wheelchair to the car, and car to the wheelchair, and then going to the elevators, and even at home you have to transition from wheelchair to a chair, wheelchair to a bed. There's a huge set of like a mobility challenge in non-flat terrain, and that's why animals are evolved to have a leg and articulated system, so we can actually go over many different variety of terrain. We still don't have a technology like that, so we're envisioning. So the reason why we've been focusing on this like a dynamic legged robot is to really conquer this mobility on the ground. What has been quite well known in this legged systems is the required strength. So we have heavy machinery. We've developed many types of machines like cars and trucks that can pull a lot of torque and forces. But when it comes to a legged system, you actually require quite high torque, not necessarily power. I can give you an example. Typical adult's ankle is stronger than passenger car engine torque. And typical adult hip joint can generate more torque than typical sports car engine. So we actually need very condensed high torque actuation, high torque motors. So that's one of the biggest challenge in the developing legged machines or like a humanoid, for example. So either we've been having either very slow high torque humanoid. Typically, you can see in Japanese and in German, there are a lot of human-looking machine that but moves very slowly. Or hydraulically powered machine, they can generate very high power through a particular joint. So Boston Dynamics, for example, is the company who developed this hydraulically powered machines, and then they can empower this machine to move like animals and go over off-terrain. Yet the efficiency is pretty serious issue in hydraulics, especially when it moves fast. So our lab has been focusing on how can we tackle these challenges and actuation challenges, so we can actually achieve both efficiency and at the same time generate high torque like an animal, like muscles. So we actually develop our own special high torque electric motors to exceed biological muscles and exceed actually efficiency of the hydraulic. So we achieved one of the most dynamic legged machine. At the same time, we actually just exceed the efficiency of the animal in locomotion. So our machine actually is more efficient than animal, and then more dynamically fast and then higher torque than hydraulic machines.